Hello and welcome to today's lesson on power. So power is a word we use a lot, but power in science is the rate at which work is done. That's going to be our definition. And so running up the stairs doesn't require any more work than walking up the stairs. It's the same amount of work, moving the same force over the same distance. But if you run the stairs, you get tired. Because the amount of time that a certain work is done is important because that's our power. So this is how much work can be done in a certain amount of time. It's kind of that's the more general terms for power. But that is your definition. You'll need to write that down and have that. Because this is a rate means how much something can be done in a certain amount of time. So rate is work over time in this situation. Because we're talking work in a certain amount of time. So power is equal to work divided by time, which is shown to you in that white box to the left of where I'm writing. Work divided by time. So again, running a given distance takes less time than walking that same distance. Therefore, you're doing more, or you have more power. And so that's what we're talking about is power. Because you're going faster, there's less time. You're going to get a bigger number when you divide those two. The SI unit for power is watt. So watts are the unit for power. 1 watt is the amount of power needed to do 1 joule of work in 1 second. So power equals work over time. And work divided by time is joules, and time is in seconds. So 1 joule divided by 1 second equals 1 watt. It should be a capital W. And then you need to be really careful of not confusing the symbol for watt, W, with the abbreviation for work, which is also a W. But this amount of power, 1 watt, is roughly the same as taking an apple and going from your hip, lifting an apple from the ground to your hip in about 1 second. So picking an apple off the floor, taking it to your hip in 1 second would be 1 watt of power. And then we have to be really careful about watts versus work in our units there. So let's do some looking at power. So the first question says, lifting an elevator 18 meters takes 100 joules. If doing so takes 20 seconds, what is the average power of the elevator during the process? So first thing, underline what you know, and then write it down. So underline all my numbers and units. So I have 18 meters. So let's put these kind of in order. So power, work, time. We'll see if we can get these. So power is what I'm looking for because it asks for what is the average power. So power, I don't know. I know I have 100 joules. Hey, that's going to be a work. And it took me 20 seconds. That's going to be a time. So in this case, my 18 meters is extra information that I don't really need to worry about. Because power equals work divided by time. I know that my work is 100 joules, so I have 100 joules divided by my time, which was 20 seconds. So 100 joules divided by 20 seconds is going to give me a power output of 5 watts. Because I only have one significant digit here and one significant digit here, I can leave it at just 5 watts. All right, let's try the second one. While rowing across a lake during a race, John does 3,960 joules of work on the oars in 60 seconds. What is his power output in watts? So again, I know power, work, and time. We'll start there. We'll see if we can fill in our blanks. And so what is the power output? We don't know. That's what we're looking for. He does 3,960 joules. So 3,960 joules of work in 60 seconds. So then we're going to go over here. We're going to have power equals work divided by time, which is equal to 3,960 joules divided by 60 seconds, which should give you 66 watts. Now I have 1, 2, 3 significant digits here and 1, 2, 3 here. So I need to make this 66.0 watts for my final answer. So that is going to be those questions. Alright, so I'll give you a chance to try these on your own. So Anna walks up the stairs on her way to class. She weighs 565 newtons, goes up 3.25 meters vertically. If she climbs the stairs in 12.6 seconds, what is her power output? So in this one, another one I know, be careful here with units. So this is where things get kind of tricky. But you have power equals work divided by time. We also know that work is equal to force times distance. So again, divided by time. And we know that force is equal to mass times acceleration times distance, which can all then be divided by time. So figure out what you know on these, and then plug them into your calculations. If you want to pause now, I will change the screen and show you your answers so you can work through them, then check yourself, and we'll go from there. So here are your answers. The first one, her power output is 146 watts. And if she would climb them in 10.5 seconds, it would be 175 watts. Here are some final review questions for you. I'd like you to be able to answer these, and then you are done for the day, and I will see you tomorrow.